Hello and welcome back to Advent of Code. I'll just go full screen on that so it's not blurry. So I decided I would do part 2 of day 15. Need to bust the cache bust that, and yeah, so part 2 was basically searching through quite a large space, like 4 million by 4 million, to find a single space in the grid that doesn't have anything associated with it. So I had a think about this. Where's that? It's like, it even tells me down here, I think. Yeah, 14, 11 for the example. So 14 across, 11 down, which we can see here, 14 across, 11 down. So it's this gap there, which, no it's not, 14 across, and 11 down. Yeah, it's this dot here, so from this, what can we tell? Not much. But we can from this, if we go to here, and I think we just need to print the map. We can just run the example for now. What I plan to do is get rid of this kind of brute force search and do it a different way, a smarter way, I guess. So here is where it is there, and if we can look at this, this center S is kind of where it is, and that B is that B there, and so it's kind of at that point there, so it should be 1, 2, 3, then 2 up. So yeah, so it's this point here, which I can't select and show you, but kind of where the mouse pointer is pointing right at. Now, one thing to note there is it's kind of, and potentially they'd pick this example as an example. This point is, at that point, it's like just outside of the diamond that we can do, and the diamond is quite computable, because basically at any point on the diamond it is exactly the distance away that the beacon is from the sensor. So using that, what I'm thinking is I can have an algorithm that goes over each of the sensors, and there weren't that many sensors. In fact, we can probably do something like print line sensors.size equals just 1 equals, doesn't really matter, I'm just printing it, sensors.size. And as I said before, I'm just going to boom, done. We're not even doing that anymore. And now if I run the example, both the example and the actual input, we should see how many sensors there are on each set. So in the example there's only 14 sensors, and in the actual input there's only 29 sensors. So what I'm proposing is basically like a double loop. So we're going to loop over all the sensors, then for each sensor we will basically loop over like iterate over the outside boundary of it, and then if those points are, so like in here it's like kind of going down there and going up there, but notably it is like not including like outside of there. Basically if it's inside this grid, which we can work out from just a bounding box, seeing where there are pointers inside, that's pretty cheap. If it's inside that point, then we take that point, say this point here, and then go through each other sensor. I mean, we can also include the sensor that we're looking, but it'll always fail. And then if that sensor is covered, if that point is covered by allow the sensor, basically if it's within the distance of that sensor to that beacon, then it can't be the answer. And eventually we should get one that in that second loop we don't actually find anything that matches, and at that point, which should be this in the example, we should know that is the point that exists. So yeah, I guess we could go about and do that. So we can get rid of that because we kind of know how many sensors. So we're going to have like a double loop, and that's one of the reasons why I checked how big it was, because this is exponential. So basically we're doing that 29 by 29 times. I think it was 29, 29 by 29 times, and maybe we can do something like that. No, but we can probably do like a math in, do we have VC? No, we don't. We can probably go 29 times, that's there, 29, and maybe DuckDuckGo it, and it will tell us the answer. Could just work in my head probably, but you got the internet, it's quick and snappy, so why not use it? So basically that's how many times we will be looping and doing whatever we're doing inside this inner loop. Now, in here we want like a mute underscore found, and we'll call this false, and at the end, if we found something, we will continue, because that means we've actually, we also need like an inner loop here. Yes, and that's right. I was going to look at the samples. Might just need to do a reset there. Samples of the jakt compiler for like iterators. Get grep iter. Cool. It should get me something. Right, so we might be able to do like something, I don't know. It's like compile time execution. I'm not sure if that's what I want. What if we just do that? So iterate, it could be like a thing. I'm wondering whether to yak shave that or maybe iterator. I guess maybe just to remind myself of the syntax, which I should know. Function we'll just do that. So we just want like a space, we'll just do that. So we can do like iterators, I guess. Then runtime preload and iterator. I kind of want to see something where it is defined. None of these are like kind of defined. So I think I might give up on that part. Because basically loop over or edge nodes. So we'll have like an X and a Y. And basically, maybe we'll start, so use X, we can do that. So this is going to be S1 dot sensor dot X, and maybe we'll start at the top. So we can just have that mute y equals s1 dot sensor dot y minus s1 dot distance, which is defined up the top. And we actually want distance minus 1. So that's going to be, if I still have it, example. No, that's not best map. Yeah, DuckDuckGo isn't liking it. So basically this is going to be this point above there to start with, which might be out of bounds conceptually, but we don't really care too much about that. And then we can go like, I think we just want to go while true. And if, yeah, maybe if x equals s1 dot sensor dot x and y equals s1 dot sensor dot y minus s1 dot distance minus 1. If that is the case, then we want to break out of this while true loop. And then we want this sort of stuff in here. Ah, no, that was the wrong key. Tab is there, tab is there, tab. And I think I actually want this outside of this loop. Do that there, and then have like another found here and continue here. And if found there, we want to break from that one. Nah, I think to go to next xy. I think that's what I want to do there. Right, so we've kind of got the first xy, and in this inner loop, we basically want to do so what does a sensor have? It does have a bounds. Yeah, we can get out of bounds. So we can get s2 dot bounds bounds dot and on a box we had a thing in bounds, and this took an x and a y. I believe, yeah, just took an x and a y, and it returned us bool. So if we are in bounds, we're going to do a thing, and yeah, if we're in bounds, that means it will be basically found equals true, and then break out of this loop. Otherwise, it's not. And then we'll go to here and go to the next xy. And so I think found needs to be false at the start of this while loop. And here the next xy is basically if our x is we want to like step, so we're here, we want to kind of work out which edge we are on. So on this edge from here to maybe here, not quite there, we would be having y is less than our y, yeah, and then it'll be like equal to y there. So if y is less than our y, but our x is greater than or equal to, so if x is greater than or equal to s1 dot sensor.x, and y is just greater than x1.sensor.y. This is top right, and here we just want to go move x over and y down, so we want to go x plus plus and y minus minus. Else, if what would the next one be? If x is greater than the x and y is greater than or equal to s1.sensor.x and y is greater than or equal to s1.sensor.y. This is bottom right, and here we want to x minus minus, but y minus minus, so y goes down and x goes back across. Else if so here x will be equal to, so if x is less than or equal to give me that less than or equal to s1.sensor.x, and y is greater than s1. This should be less than up here. Sensor.y, and in this case we want x to go that way, but we want y to go back up. And we'll just do an else for the last clause, and maybe we will put in a comment to say this is bottom left and this is top left, and in the top left we will want to push x over, and we will want to raise y. So I think that kind of does it. And if that is the case, and if we get back, so we'll do that loop there. And if not found, I think if not found, we want to break out of this thing and not do that, because that means that we have found a particular thing that kind of matches. So if not found, that means we have found it. Otherwise, if we find it, then we loop back and we'll break at this point if we kind of get back to the top. So we'll start there, we'll go all the way down there, we'll go all the way down there, we'll go all the way there, and we'll go there. And when we get back to here, using those same rules, it should break out of that. Marked as found, because we found something that overlaps there. And so here we can just continue. So I think I will just do stuff here. Print parts 2, and here we can probably just do a break. Yeah, that looks actually quite nice. So we I might keep that comment there, and we kind of need that found to be in that scope. That should be stepping through everything, and at this point we should have an x and a y, and I forgot what we meant to do with it. We meant to print line part 2 can be something, and it can be x times 4 million plus y, and then we can break out of that, which will take us to this one. Yeah, so it's a bit bigger code, but so here we saw that we were failing on the example, and if we run it again, I hope that it will still fail because it's printing out this map, but it won't show us the diff of part 2. it won't compile. Gosh, is that like an LVM? Right, that's like assertion failed pointer. I'm not sure what's happened with my Serenity. It's like the taskbar is like kind of stopped doing. Right, I am unsure why this is doing it. Day 15.jakt. How come it failed there? Right, so we get the wrong answer. That is kind of odd that. Right, yeah, we get the taskbar back. Yeah, it's kind of odd that playing error happened. Yeah, like it failed some assertion. Right, so we're getting the wrong answer. So I think what we want to do is kind of print the map every time we do this, but our bold will be a lot smaller. So here I think we can print our map, and our bold can just be a box, and origin. What we can do is let p equals point x y. Yeah, I think that's just what we want. And then here we can origin is p and corner is p, and I think that will kind of just print the map each time. Right, it didn't like that because we need an extra bracket there. So what I'm hoping now is it will kind of print through the path, like the candidates that we're looking at. And I think I know what our issue is. Yeah, we're looking at stuff that is like nowhere near where we're meant to be looking. Say like this one here is a dot, and interestingly that's a dot, but then that's also a dot. So we're not doing a check for if search box dot in bounds x y we kind of want to go to the next one. And I think to do this, I'm gonna, because I want to basically run this thing, which is why I kind of want an iterator type thing. But instead, I'll do function move next, and it's going to take a mutable x, which is going to be 964. It's going to take a mutable y, which is 964, and it's going to take a s, which will be a sensor. And it will just change the XY. So I'm hoping we can just kind of take that chunk and put it there, and maybe go move next X, Y, and S1, I guess, and maybe we'll make that anonymous. In fact, we could probably like do something like that. Yeah, that looks good. That looks good. And maybe we don't need to make that anonymous. The mouse is doing some weird leggy things. So if in this case, we kind of want to do that continue, but we also want to do like that, I guess. Maybe we can do that if not that we can break, and we can just return this condition, return that, that's all good, and then this will return a bool, and so now we don't need this, I guess, and we can copy that over this thing. And here we can just go continue, because we're not in the search box, so we could go like while, then that break wouldn't really work. So I might just do that, and I'll kind of do that, and that point can just be there, and what's happening here? Nothing. So this point here, I think I want to just do some Vim magic. And do that, and not that, I guess that, that's alright over there, I think, and maybe go back to here, and because Hack Studio commonly crashes when you edit outside, I'll do that and reopen it, and I realise these all have S1, which we just want S. Probably could have done that in Vim as well. Cool, so that makes this a bit easier, and we can see where we get it. And maybe here we can go found equals that, x equals that, y equals that, found x, y, just to get a bit of debugging, and I might do a reset just again and run that example again and see what that does. We get that error again, and yeah, it's like done that same thing with Serenity, like it's done that. Right, if I just compile it like that, that's really bizarre. I'm unsure why that does. Right, so here we have this, and yeah, so I think my issue is we are not going far enough out. I think I do want to put this here. And here we can go print line out of search area. This will probably fail. No, it won't. Yeah, that's really bizarre how, or yeah, it will. Unsure what's happening there, but we can compile manually. So here, this is our search area. I don't know which, well, it's running off this example input, so it's running off the sensor at 2 to 18. We don't really have numbers here, but we can kind of relate it to this. 2 to 18 will be that S down there, so like this S here, I think. So yeah, this should be covered by something. Yeah, found true, so it does that, and then it goes like somewhere completely different x2, y10. So we should be going to move next. Print time back at start. That's just breaking out that back at start. And I feel like something is not right in this part here, the move next. Oh, this is going to fail again, isn't it? No, it's not. Just it sometimes does, sometimes doesn't. Right, so we start here. We're printing out, so that's right. So we're looking at that point there. We found it. I think I want to see where I found it. Where do we found it? There. Print line found by S2, and that should just pretty print it out. I kind of like how jakt you can just have everything kind of formatted nicely. Right, so we're looking there. So that one is found there, and that kind of makes sense because it is there, and 210. 210. Sensor is 878787, and that 210. So yeah, that kind of makes sense. It's found that, and then we're like back at the start straight away. Yeah, that's not quite right. X is 2 and Y is 10. So I think I want to print line x equals that, y equals that, s dot x equals that, s dot y equals that, and we can go x, y, s dot sensor dot x and s dot sensor dot y, and see what that prints. Because yeah, we're not iterating around the whole diamond. So at this point here, is that right? So we start with it being x. Yeah, we start with x being the same, which looks right, and y is, I guess we could show the distance, but y should be basically y minus the distance. So we should be in this point here, and so x is greater than or equal, and y is less than, yeah, y is less than s dot y. So that means we should plus plus x, and we should be plus plus in y, we should be going further down. So yeah, there should be 2 y minus minuses, and there should be 2 y plus pluses. There should be 2 pluses on the x and 2 minuses on. So maybe that fixed that bug. Have another C. Still get the wrong answer, but we may have got like one more. No, we didn't. I think I want to include in this s dot distance equals that, and everything just to so we can see that it's doing the right thing. And if it's not, I'll probably give up because can come back to it. Can come back. So we have that. So X should go across 1 and Y should go down 1. And then we, for some reason, think that we're back at the start. But we're not. So I guess maybe this case is wrong back at the start. So if we want to not this entire thing, because we're returning true if we've done it, and that probably will fix that bug. And hopefully we'll get the right answer. Who knows? Who knows? We compile. Looks like we've got an endless input. And it looks like we're just looking at the same one over and over. Yeah, so that's like not really changing it. Yeah, like this move next is not actually altering the X and Y like it should be, and it is mutable. Yeah, I think I just need to take a break and work out how jakt is meant to be doing this. Potentially I need to return the X and Y as like a tuple. Yeah, so I think we don't want mutable and don't want that, and we probably want mute X ret equals X and mute Y ret equals Y, and do that. And here we can, I'm happy that's doing that. We can return a tuple of, wow, like maybe let con equals that thing. And we can return a tuple of X ret, Y ret, and cond. And we can reflect that here by returning an R64, R64, and bool. And I wonder if we are allowed to do that. Try and compile. Nah, we're not allowed. We might be allowed. We might be allowed. So what we can do is mute cond equals false, I guess, and X, Y, cond equals all of this, and if not cond, do that. And so there we will copy paste that down to this one as well, and we'll get rid of that to do, I guess, and see if this does it. Yeah, it doesn't like that. Yeah, so we're just here. So I guess what we could do is let X new and con do that, and otherwise we then go X equals X new and Y equals Y new. equals x new and y equals y new, and get rid of all those spaces. And that looks like it compiles, and we'll see if it's an endless loop again. Cool, that does something. It still gives the wrong answer though. So we go there, back at start. Yeah, so we're just back at start again. There's something weird going on. So I think hello and welcome back to the same video. I think I'll just join them up. I was working on Advent of Code part 2 for day 15. Had some issues with MoveNext not doing the right thing, and like I couldn't have mutable stuff, so I'm like now just returning a tuple with the new results. I'll get rid of the printable stuff, and some of these plus and minus were round the wrong way, and I wasn't actually using the xret there, I was using just x, so that wasn't working. Once I got that, I was still having issues, so I hard coded the right answer in and found that I'll get rid of some more print stuff. Yeah, I found that this, I just changed this to be what it is now, but it was like if s2.bounds inbounds, and that was failing because if we look at how the bounds works out, it doesn't really work out the diamond, it works out the square that encompasses the diamond. So if we say look at day 15 and do that, so the square would actually be like from that point down to that point and across to there. So when we're at this point, which is the answer, it is within that square. So I changed that to just have if the distance from the sensor to the point, which we get there, and I guess we'll keep it in there, but I'll comment out that print map, I guess. Well, it shows where the search box is, but yeah, we won't want this in for actual prod. But yeah, now with that change, it is getting the right answer, which we can confirm if we take out all these prints. We should get and the issue I was getting where it wasn't compiling was actually I was running out of memory, because I forgot to bump up my virtual machine to have 5 gigs instead of just 1 gig. So here we see it fails, but it doesn't actually fail. Basically it tests this point and prints out the answer. So if we run that just without less things, we see we get the part 2 answer of that, which is what the expected output is meant to be. So what I'll do is take out the hard coding, because I still don't know whether it actually works, and if we run it again, it will still fail the test harness because we're printing out the map, but hopefully yeah, so here we can kind of see what it did. So it started at it started all the way there, and it kind of traversed down that diagonal and did the thing. Now I will also go into day 15.example because I just made it have the sensor that it would have it in right at the start. So if we run this again, yeah, I think it's doing it. If we do that with less, we should get, yeah, so we're getting like this beacon, and that does like a loop around there, and then eventually it will basically find the thing, and like this probably spits out like a bunch of stuff, yeah, like 2,000 lines of of stuff, but it gets the right answer. So what we can do is not print out the map and run that again, and it should just give the green pass, which is fine. Interesting, I noticed when I rebooted the machine, so in Serenity I actually got a few new changes. So I'll close that browser, and normally what happens when I close a browser is I have to do a bunch of logging in stuff, but now when I go here, you'll see that I'm actually logged in already, which I guess maybe some people saw my video and fixed that like cookie persistent issue. I was gonna look into it, but I just never really got around to it. So that means that I don't have to like muck around with secrets, and I think it potentially also has cache busting, but I'm not too sure. But if we run this against the actual input, it takes a while. I haven't actually run it against the actual input here, but now the search space is a lot bigger, and it still gives an answer. I am amazed. Can I paste in there? Paste. No, I can copy, but not paste. Can I paste like that? No. 106. Oh, can I even click on it? Right, I think I've had this bug before. If we like make that a bit bigger, 106. No, can't paste. 106.937.313.08.112. I assume that has done it. And yeah, that is the right answer. It's a big number. Luckily we have i64s to kind of carry this, to be honest. But yeah, if we then outputs day 15.output and paste in that, and then run that again. How long did it take? 10 seconds, gosh. 10 seconds is quite a while. And if I go back here, it doesn't do cache busting, so I don't have that star there, and it still just says 29 there. But if I bust a cache, then I should have 2 stars. That looks good. Cool, so this, we basically took away the brute forcing and put in this quicker solution. It still takes like 10 seconds, but I'm happy with that. And cool, I'll add that in and commit that all up, and we'll call it day 15 part 2 efficient. And we can quit that, and we can push. Now we'll need to do a thing, ch mod that, and we'll push. We might even need to pull it as well, because a day has happened. No, the day hasn't happened. I guess I started it then. But yeah, thanks for watching this video, and I'll see you next time for day 16, I guess.